Good afternoon to everyone. Today I discuss about the continuity. Last class I discuss about the limit, definition of limit, some properties and some example. Okay, that is the 2 marks for one question and 5 marks for another question. Okay, in continuity, this is the 5 marks question is coming in your annual exam. Here today I explain some theories there means what is the continuity and some properties. Here, the continuity means in the definition of the limit f of x, the function f of x has x tends to a. We have considered 0 is less than x by a, which means that is the x is not equal to a. Thus, in the context, that is the context of the function f of x is not to be a, define a x equal to a. Okay, see here, your definition is there. Your definition, continuity means a function f of x is said to be continuous at the point that x equal to a if for a given positive number, it is the epsilon. You remember this definition? A function f of x said to be continuous at the point x equal to a if for a given positive number epsilon, then there exists the delta is greater than 0. Okay, so that the some equation that is the delta is greater than means you take here the mod of f of x minus f of a is less than epsilon. Mod of f of x minus f of a is less than epsilon for every x for which that x, you remember this one, okay, this term, for every x for which x minus a is less than lambda. Okay, by recalling the definition of the limits, we can say the function f of x is continuous, means we are taking the function f of x, this is the continuous means that x equal to a if limit of x tends to a, f of x equal to f of a. Okay, remember this one. Limit of x tends to a, f of x is equal to f of a. Okay, hence for the f of x is a continuous at x is equal to a, the following three condition must be valid. Means three condition is there. First one is f of x must exist and finite. Remember this one. F of x must be exist and finite. Second one, the left hand limit and right hand limit of f of x, that is the function as x tends to a, both exist are equal. Means this is the LHL left hand limit and RHL right hand limit of the function f of x, then x tends to a, both exist and equal. Exist are equal so that the limit of x tends to a, f of x exists. That is the second condition. Next, third one is the limit of x tends to a, f of x equal to f of a. When the function f of x is a continuous at every point of a given interval I, then it is called continuous over the entire interval I. Next, see here, three condition is over. Next, see here, if f of x function is defined over the closed interval, that is the AB, then the first condition is there. F of x said to be continuous, then x equal to a if limit of x tends to a plus f of x equal to f of a. Then second one, f of x is said to be continuous at x equal to b. Then limit of x tends to b minus f of x is equal to f of b. Remember this one? The limit is continuous, the function is continuous at x equal to a, if x equal to a means if the function is, that is the limit of x tends to a plus f of x equal to f of a, and x equal to b means that limit of x tends to b minus then f of x equal to f of b. Okay, this is the both two properties there, two condition. Remember this one. Next example of the continuous function means here some three example is there. First one is f of x equal to k. A constant function is continuous for all x belongs to R. The function f of x equal to some constant, that is a continuous. Next second one, f of x equal to, that is a naught plus a1 of x1 plus a2 of x square plus a3 of x cube, then so on. The n of xn, that is the polynomial function, is continuous for all x belongs to R. That is the second one. Okay, next third example, that is the f of x equal to e to the power of x or sin x or cos x is continuous for all x belongs to R. Okay, this is some example. Next, fourth one example is f of x equal to some function, that is the tan x. The tan x is continuous for all x belongs to R except at x equal to that 90 degree pi by 2, 3 pi by 2, 5 pi by 2, then so on 2n minus 1 pi by 2. That is the fourth example. Next fifth one, a rational function f of x divided by g of x, where f of x and g of x are the polynomial function, is a continuous for all x belongs to R except at the value of x where g of x is equal to 0. Next, some notes is there. You read this one. The geometrical continuous of the function f of x at x equal to a means the graphs of a function f of x has no break at x equal to a, and it does not jump immediately to the point above and below of the line y is equal to f of a. Next, discontinuity is there. Discontinuity means when a function f of x is not continuous of the point x equal to a, that is if any one of the following three condition is valid. First one is f of a does not exist. F of a does not exist, that is f of a is not a finite, means that is the infinite. F of a does not exist means that f of a is not a finite. Next second point, limit of x tends to a, f of x does not exist. First function f of a does not exist. Second one, limit of x tends to a, f of x does not exist. That is a discontinuation. Next, third one, both f of a and limit of x tends to a, f of x both exist, but the f of a is not equal to limit of x tends to a, f of x. Then f of x is said to be discontinuous. Okay, at x equal to a, and the point x equal to a is called a point of discontinuity. You remember this one? Discontinuous and point of discontinuity. Next, go to a types of discontinuity. Types of discontinuity means there are a following types of discontinuity. First one is removable discontinuity. First one is removable. A function f of x is said to be removable or a simple discontinuity at the point x equal to a if limit of x tends to a f of x exists and is finite, but f of a is not a defined, or even if f of a is exist, then f of a is not equal to limit of x tends to a f of x. This is removable discontinuity. This is known as a removable discontinuity in the sense that f can be made continuous by a definition. Next, second point, when limit of x tends to a f of x does not exist, or even if it exists, it is not a finite, then f of x is said to have a irremovable discontinuity at x equal to a. Next, third one means there removable discontinuity is there. Irremovable discontinuity. I underline this one. First one is removable discontinuity. Then irremovable discontinuity. Next, discontinuity of the first kind from the left. Next, LHL. LHL means left hand limit. When left hand limit is equal to limit of x tends to a minus f of x exists, but not equal to f of a. F of a, then it is called a discontinuity of the first kind from the left at x equal to a. When right hand limit is equal to limit of x tends to a plus f of x exists, but it is not equal to a f of a, then it is called a discontinuity of a first kind of from the right at x equal to a. Means here we discuss the definition, the removable continuity, then irremovable of continuity, discontinuity, then left hand, the discontinuity of left hand and discontinuity of right hand. Next, go to a report. और इलेक्ट्रिक डिपार्टमेंट वगैरह आमेಲೆ ಕೊಡ್ತೀನಿ ಓಕೆ ನಾಳೆ ಬರುತ್ತೆ ಲಾಸ್ಟ್. ನೆಕ್ಸ್ಟ್ ಒನ್ when both LHL ಮಿಸ್ ಆತನದ್ರಮ್ಮ when both LHL is equal to limit of x tends to a minus the f of x and RHL is equal to limit of x tends to a plus f of x exist finitely but are not equal to, then it is called a discontinuity of the first kind. Okay, you only studied this definition. You next go to here. For example, is there first one is the function f of x equal to, see here, that is the x square minus 1 divided by x minus 1. That is the first one. That is the if x is not equal to 1. Next one is 0 if x is not equal to 1. Poses a discontinuity of the first kind at x equal to 1. You remember this one? LHL means that is the limit of x tends to a minus f of x does not exist. That is discontinuity of a second kind of the function from the left at x equal to a. Next, RHL means that is the limit of x tends to a plus f of x does not exist if it is called a discontinuity of the second kind from the right limit. Okay, at x equal to a. When either LHL or RHL or both of the not exist, that is at x equal to a, then it is called a discontinuity of the function, that is second kind. Okay. Next here, the two general example is there. The second example is the function f of x equal to sine of 1 by x if x is not equal to 0. Then second one is the 0 if x is equal to 0, has a discontinuity of the second kind of the function, that is x equal to 0. Okay, here what example is there? One for 5 mark question. See here, discontinuity Discuss the continuity of the function that f of x equal to x plus 7 divided by x minus 3 over the set of real number r. This is your question. Discuss the continuity of a function that is f of x equal to x plus 7 divided by x minus 3 is there. Okay, first you take the solution. The function f of x is equal to x plus 7 divided by x minus 3 is a polynomial rational function. Okay, then at x equal to 0, suppose you take x equal to 0 means it is a plus 0 minus 0, that is sorry, minus plus sorry, at x equal to 3, then plus 3 minus 3 cancels, the denominator is 0. That's why at x equal to 3, the denominator of the function becomes a 0. Okay, then f of x is a continuous. Means 0 by anything is 0, but here anything by 0 is there. Okay. Hence f of x is a continuous for all x belongs to R except at x equal to 3. Then suppose x equal to 2 means that is a 2 minus 3, that is a minus 1. Okay. Then x equal to 3 is a point of discontinuity of a f of x, the function. Next, second one. Discuss the continuity of function f of x equal to mod of x at x equal to 0. This is your question. Discuss the continuity of function f of x equal to mod of x at x equal to 0. Okay, you know that. Next solution, the mod of x equal to minus x and plus x. Means mod of x means always the mod means that is the positive. That's why we take here minus x and plus x. Minus x means if x is less than 0. The plus x means that is if x is greater than or equal to 0. Okay, see here. We take here formula that is the left hand limit and right hand limit. LHL first we take now. LHL is equal to limit of x tends to 0. It is the f of x equal to limit of x tends to 0. F of x means that function is first one is minus x is there. The minus x that is equal to limit of h tends to 0. Then minus of that is the minus x means we take here applying the that limit that is x tends to 0. 0 minus h that is equal to 0. Okay, next one RHL. RHL, the limit of x tends to 0 plus that f of x function is equal to limit of x tends to 0 plus that x plus x. The second point is that plus x is there. The limit of h tends to 0, that is 0 plus h. That is equal to 0. Okay, therefore the LHL is equal to RHL. Means we take, you write here LHL is equal to RHL is equal to 0. Thus the limit x tends to 0, f of x equal to 0, that is equation 1. Also by definition, that is the what is definition? The function f of x is equal to mod of x at x equal to, sorry, mod x equal to x at x is greater than or equal to 0. Then the function f of 0 equal to 0. Okay, this is the second equation. From 1 and 2, the first equation is f of x, limit of x tends to 0, f of x equal to 0, that is the first equation. Next, second equation is, that is the f of x is equal to mod x is there. That first and second means that is the limit of x tends to 0, f of x equal to f of 0. Okay. After that, hence the function f of x is a continuous at x equal to 0. This is the second one. Okay, third example. This is also same. You see this one. First, you take the f of x function. Is discuss the continuity of function f of x at x equal to 0. If the function given function that is f of x equal to 2x minus 1, that is the x is less than 0. Suppose 2x plus 1, that is x is greater than is equal to 0. First, you take the LHL and RHL. After that, you prove LHL is equal to RHL. But in third example, the LHL is minus 1 and RHL is plus 1. Therefore, the LHL is not equal to RHL. Then limit x tends to 0 f of x does not exist. Hence, f of x is not a continuous at x equal to 0. Okay. Only we take the LHL and RHL. After that, you prove that one. LHL is equal to RHL. Otherwise, LHL is equal to not equal to RHL. Okay. You see this one. Fourth one also same. First, discuss the continuity of function f of x at x equal to 2. If f of x equal to x plus 1 given, that is the x is the condition x is less than 2, then take the second point, that is 3, that is x is equal to 2, then 5 minus x, that is the x is greater than 2. First take the LHL, the function f of x, that is the x tends to minus 2, x plus 1, that is equal to limit of h tends to 0. There, where x is there, you take the 2 minus h plus 1. Then h is there, the h tends to 0 means you take the h value is at 0. Then RHL, the limit of x tends to 2 plus f of x is equal to limit of x tends to 2 plus, that is the 5x minus second point, 5 minus x, that is equal to limit of x tends to 0, 5 minus 2 plus h. That is equal to 5 minus, that is simplification, 2 h means that is the value is x, h tends to 0 is there, that is 2 plus 0 is 2, 5 minus 2 is 3. Means that LHL and RHL are equal, that LHL is equal to RHL is equal to that 3. That is equal to limit of x tends to 2, that f of x equal to 3. Okay. You see this one. After that, also finally you write here. Also a definition that f of 2 equal to, that is 3. Next condition is there. Next continuation, that is limit of x tends to 2, that is f of x equal to f of 2. Okay. Limit of x tends to t. Sorry, I am saying here limit of x tends to 2, f of x equal to f of 2. Hence, finally you write here, therefore, hence f of x is a continuous at x equal to 2. F of x is continuous at x equal to 2. Okay. Next, tomorrow class, I will discuss the next example is there, continuity example. Okay. After that, the completion of the continuous function means algebra of the continuous function is there. Maybe 3-4 class get over this 2 class for this chapter. Okay. Thank you for all.